So number 5, we need to add them. And so what we first need to do is simplify first. So looking at this, here it's an index of 4. So 16, I can simplify 16. And then end of the fourth, I need to simplify that as well. So I know I need to work on the left side. Now on the right, I have 7n fourth root of q. So there's nothing here I need to simplify. So this is nice. I don't have to do anything to the right, but I do have to do something on the left. So let's work on the left. 16 is 4 times 4, or 2 times 2 times 2 times 2. Okay, so I'll do it right here. Square root of, or fourth root is 16. Fourth root means I need 4 of something. So 16 is 4 times 4. Or since I need 4, I'm going to break it down even further. 2 times 2 times 2 times 2. Now there's 4 of them, and so that's a perfect 2. Okay, so that's why I wrote down 4 2's here. Then I have n to the fourth. That's okay. So they're the same exact index, so I'll be able to circle that, and then I'll have a q left over. Then I'll write the rest, 7 and fourth root of q. So at the end, this left side that I'm working with should have the same exact radical, right? Same index, same radicand inside, because then I could add them. So for our purposes, it will always work out. So if it doesn't look the same, then go back and double check. All right, let's circle R. We need 4 of everything because our index is 4. So that 2 comes out as a single 2. The end of the fourth comes out as a single n. Then we're left with fourth root of q. Then bring down the rest, 7n fourth root of q. So everything is the same. So now we just combine like terms. 2n and 7n, that is 9n. And then you just write the rest, fourth root of q. Let's try this one. Cube root of 216, p to the ninth. So cube root of 216. So hopefully you see 216 is really just 6 to the third power, because we've been using these over and over again. So 6 to the third power, 6 times 6 times 6. P to the ninth, we can rewrite that. I don't want to write P 9 times. Let's say P to the third, right? So it needs to be the same index, P3, P3. Now remember, we're adding the exponent. So 3 plus 3 is 6, so I need one more. 3 plus 3 plus 3 is 9. Now I need to circle 3's, sets of 3's. So now I have, this comes out as a single 6. That comes out as a single p, another p, and another p. Then to simplify all the way, that's 6p to the third power. Number 7. Fifth root of 32 over fifth root of x squared. So if you can simplify, start with that first. Fifth root of 32, I hope you see that that's 2 times 2 times 2 times 2 times 2. It's perfect. And then fifth root of, I'm going to leave it as x squared for now. So this is perfect. That's going to come out. And so it's going to be a perfect 2 in the numerator. So do that first. Then write the rest. And so it's fifth root of x times x. My index is 5. So I need 3 more of those x's. So fifth root to the top and the bottom. I'm rationalizing the denominator. And so now the numerator, so I just multiply across, so it's not in the radical, this 2 is not in the radical, so I just write it as 2 fifth root of x times x times x, or x to the third power. Then the denominator, that becomes fifth root of x times x, and then 3 more x's. And so now there are 5 of them, so that's perfect, right? That was our goal. We want to rationalize the denominator. You're not allowed to have radicals in the denominator. And so now this is done. Last problem. We need to rationalize this problem as well. It's 1 over 3 plus root 2. Now to rationalize the denominator, we multiply by the conjugate. Remember, the conjugate is the same exact terms, but opposite signs. Okay, same exact terms, but opposite signs. So when we do that, it's the same term, 3 root 2, but it's positive, so now I need a negative. Remember, the reason why you need a negative is so the center can disappear. If I were to multiply this conjugate, a plus b times a minus b, remember that is just a squared minus b squared. Because when you do the FOIL, a times a is a squared. Negative a times negative b is negative ab. Then this is b times a, which is a positive ab. And then b times negative b is negative b squared. Notice that the negative AB and the positive AB cancel out. So you don't even have to think about that. Just know in the denominator, it will be a squared minus b squared. That'll help us out greatly. All right, so let's get back to this problem. Let's finish multiplying. So what's nice is the numerator is just 1. So we're going to just, it's just 1 times 3, which is 3, times a negative root 2. So same exact thing. Now what I said earlier, the denominator is just a squared minus b squared. So this is going to be a is 3 squared minus b squared. B is square root of 2. So square root of 2 squared. So let's simplify the numerator. 3 minus root 2. 3 squared is 9 minus square root of 2 squared. So I hope you see that that just cancels it out, because square root of 2 times square root of 2, there's 2 2's in there, right? So it's a perfect 2. So 9 minus 2. So be careful. Then we simplify 3 minus square root of 2, and then 9 minus 2 is 7. And now we are done. Okay, so those are the topics that are on the quiz. And then the other thing you want to take a look at is the graphing we did in class. So graphing something, so the example we did in class was like square root of x minus 4 plus 2. So identifying the index, the transformation, graphing the parent of square root of x, and then also identifying domain and range. And then the other piece of that as well is writing a transform radical function as well that we did in class. Okay, so example 4s. All right, thanks for watching.